So once upon a time, I was a security researcher. I worked on mobile security and web security as a grad student, and then I built key parts of Chrome security UI that you probably use today, maybe even if you don't use Chrome, since many of those ideas or even the code itself made its way into other browsers. Today, as we speak, I'm a director of engineering on the Chrome browser team, and I manage Chrome's data science and engineering, iOS, and content teams. You'll notice that security is conspicuously missing from that list, and that's one of the things I'll talk about today. So over the last 10 years, I've experienced 3 transitions that I wanted to share with you today. I'm going to tell you 3 stories about change and lessons learned. The first one is about Chrome. Chrome, when I joined, started off as a small niche product for nerds in the US. And over years, it became a large global product used for everyday life. And this had major implications for how we made decisions, including about how we make decisions about security. During the same time period, I went from being a researcher to a practitioner. I learned a lot about how research and industry relate to each other. And the third story I'm going to tell today is about how I switched from working specifically on security as a subject matter expert to doing general product engineering for Google. And in the process, I learned a lot about how security skills do and don't translate to other areas. All right, so for our first story, let's start by rewinding the clock to 2012 and talking about a product called Chrome. To get your brain in the right space, this is the year of Call Me Maybe by Carly Rae Jepsen. The Hunger Games movie was just released. It was a leap year. Barack Obama was elected his second term in office, and Chrome was a small browser. Now, let me explain what small and big mean in this context. Big, like Chrome is today, means a few billion actives. In contrast, Chrome was small when I joined in 2012, something like 100 million actives. Now, I recognize that there are 300 million people in the United States, so I understand that 100 million monthly browser actives might sound like a lot, but it is cozy compared to a few billion. So it's 2012, we're all blasting Carly Rae Jepsen. I joined this close-knit engineering team who likes to ship software to their 100 million best friends. And at this point, Chrome engineers and PMs were mostly building for themselves. The founding engineering team wanted a browser that was simple, fast, secure, and stable. Luckily for us, it turns out that's what a lot of other people wanted out of a browser too, because Chrome is growing pretty nicely, especially in the United States. Over the next few years, though, the world of computing started going through a change. You might not have even noticed it if you live in the United States and don't stare at browser statistics for a living. But if you lived in India, Indonesia, Mexico, another of other countries in the early 2010s, I bet you saw what happened. Everyone got a cell phone, a smartphone. There are 1.38 billion people in India, a few hundred million in Indonesia, more around the world. All of these people getting their first smartphones. Many of these people didn't previously have desktops, so this was their first exposure to the internet. Or maybe they had access to a desktop, but it wasn't theirs. This huge computing growth was happening, and frankly, we were kind of missing it. The people getting their first phones in that moment were different than knowledge workers and office nerds in California, even those of us with origin or family ties in those countries. Those people who were getting their phones for the first time were and are different in a few key ways. They're mobile first, good chance that they're mobile only. That means that they're not necessarily familiar with desktop browser paradigms like tabs. They're not necessarily familiar with iconography or concepts that have been used in computing for a long time on desktops, like a floppy disk for a save icon or a lock for a security icon. There's no reason to assume that they have the same threat models or privacy goals as American knowledge workers. And they probably don't read or write English as their first or primary language, regardless of what their device is set to by default. And it is surprisingly common, or at least it was at the time, for devices to be set up to English, regardless of what language the person spoke or read. Now, UC Browser, I don't know how many of you have used it. Maybe you used it if you're from one of these countries. Was built in China with an Indian market in mind. And they were eating our lunch. They're building a great product. We had a lot of work to do to catch up. The Chrome team saw this, our product leader at the time saw this and started to adapt. Product leadership was very clear. We can't just build for American office workers and like hope that somehow that product works for the rest of the world. We traveled, we did user research, and we started to learn to rely on data instead of just intuition. The Chrome team has come to rely on telemetry to help us make decisions about what to build and launch. Telemetry refers to large-scale aggregated pseudonymous data collection. How many people clicked on that browser button? How long do pages take to load on average, etc. Telemetry has lots of advantages. You can do statistics and feel extremely fancy about yourself. You can publish papers that have very fancy numbers and statistics in them. It can tell you that your feature is buggy and cause 300 million people, the size of the whole US, to wake up and have their browser crash. Bad day. It can also tell you that your shiny new phishing warnings are working pretty well. Good day. But telemetry also has a lot of limitations, particularly in security. How do you turn security concepts into a number that you can measure at scale? Sure, okay, in some cases, you can do that. Like, how convincing is that warning? You can see how many people click through it. That was what I worked on. That's a very kind of canonical, measurable problem that you can track. Do people use our password manager? Bam, that's a standard feature metric. But who are people worried about being protected from? And are we achieving that? Do people understand what incognito mode does and does not offer them? And is that understanding serving them well? Do you even care about phishing if you don't have a credit card or bank account and always pay for goods and cash on delivery? This is where telemetry fails us, but traditional user research comes in. Interviews, surveys, lab studies. Chrome built up a really strong user research team focused on trust and safety. I'm really glad to be able to work with them. And in my opinion, security needs more traditional user research than other areas because it's harder to quantify than typical data science as applied to products. Now, one thing that we learned from user research during this time period was that security decisions made for knowledge workers in California, or those trade-offs made for that demographic, weren't necessarily going to be sensible for middle-class Indians, in 2013, 2014. Now, here's one example. If you all here today were given the choice to proxy all your HTTPS traffic through a third party in exchange for a small speed increase, knowing that that third party will make unspecified changes to your HTTPS traffic, would you do it? I wouldn't. For me, in this context, the speed increase wouldn't be worth the fact that I'd have to be trading off trust in this proxy. But in the early 2010s, UC Browser shipped with a proxy server to speed up page loading and rendering. Both HTTP and HTTPS traffic went through it. They were doing some mix of caching on local in-market servers and page transformations. This required trusting UC Browser a lot with your traffic. But it came with the benefit of making pages load a lot faster. And in India, where a lot of people were on 3G and bandwidth was very expensive, like people, some people were putting a pretty big chunk of their weekly earnings into getting access to the internet. This trade-off makes a lot of sense for them, and I could understand why they would choose that. And so, people, when we were talking to people were asking Chrome to do this. They wanted Chrome to be faster and cost them less money. And, our senior leadership team, which I wasn't part of at the time, faced a really hard choice. Should we ship a similar feature? People are saying that they want it. Now, I, at the time on the security team, was working really hard to try to move as many websites as possible to HTTPS. And my reaction was like, how can we be pushing for HTTPS adoption and then also be shipping features that route content through Google servers and modify them? Like, this is a really hard call because that's exactly what people were asking for. But for me, with my security hat on, I was deeply uncomfortable with it, right? But it's a hard trade-off. Now, Chrome did end up building a compression proxy, but limiting it to HTTP pages only. And it was retired when HTTPS became too prevalent for it to be widely useful. Now, luckily, page load speeds also caught up a lot and bandwidth costs went down and became less of a concern. I believe that UC Browser doesn't do this anymore either as a result. But it was a really hard problem with good points on either side and an example of different user groups weighing security trade-offs differently. Today, we're a big product, a product with several billion actives spanning all kinds of wildly different people. We face hard trade-offs between constituents like this all the time, not just specific to India, and it impacts the security features we ship. Now, in my opinion, the hardest type of trade-off happens when the preferences of vocal tech people differ from the preferences of less tech-savvy people. And this can happen in lots of contexts. Tech people tend to have super strong opinions and preferences and will share them widely. Their opinions are likely to make it to the press, but they're a relatively small group. There are a lot of people who struggle to use their phones or laptops and who pretty much do that struggling in silence. And so sometimes the features that you try to build for the latter group can come across as annoying or dumbed down or patronizing to the techie demographic because they're not experiencing the same use case or need for it. And so this can become a very real challenge to figure out how to balance the needs of the groups. Another thing that changed along this path of growing from a small product to a big product was our sense of responsibility. Chrome has always wanted to be stable and secure. I mentioned earlier that those are core original value proposition of the product. But when you have a few billion actives relying on your feature, you will be highly aware of and anxious about the consequences of mistakes. Crashes, 0 days, these things affect real people, more people than you'll ever meet in your entire life. If Chrome doesn't work, someone can't finish their homework, someone else can't apply for that job they really need. There are consequences for real people. It's resulted in more investment in process, testing, reviews, and certainty at the trade-off of engineering and launch velocity. We are absolutely not move fast and break things. We are not a building that gets built up in the neighborhood overnight. We're like a brick house that's getting carefully, incrementally put up brick by brick, until we have the next floor of the building. And this is really tricky because deprecations are often a key strategy of web security, where there are, old features that we don't think are secure, web features that we don't think are secure anymore, a JavaScript API or a CSS feature that we want to deprecate. But, if deprecating that breaks 10 million websites, what are you going to do? You're going to shut down a small business that doesn't have, or maybe tens of thousands of small businesses that don't have people to update their websites to handle the deprecation. So, this desire for stability becomes a real challenge. Now, before we move on to the next story, I want to just quickly recap. So Chrome went from small to really big, and 3 things changed. We had to move from intuition to user research and data science. We started needing to make challenging trade-offs between the needs of groups of people in the process of trying to build a browser for everyone. And our heightened sense of responsibility has led to investment in process testing and reviews, as well as a lot of caution around breakage. I'm going to pause now before I go on to my next story. Are there any questions about this part, about Chrome's growth or what it's like to run a big product?
Maybe I'll jump in to warm up. So this is really fascinating, I think, how you've explained how you've seen the journey from Chrome being a small browser to like a big product used by billions of users. And I think also fascinated by your point about now needing to move slow. But I want to ask you about the tension you feel when there are like other like smaller browsers out there, for example, Brave and DuckDuckGo, who can move fast and can break things and possibly can do more innovative and experimental stuff. So how do you see that tension play out, maybe inside Chrome team or in the browser community at large?
I mean, that is spot on a real problem, right? Sometimes I see other browsers, other products doing things, and I'm like, oh my gosh, I would love to do that. Except if we do that, we'll cost other people money or we'll shut down their website. And it's a real challenge. It definitely causes us to employ a lot more strategy people and product managers who can think about these really hard questions. But there's no really good answer. We need to try to figure out how to change. But realistically, it's going to be a little bit slower and a little bit more cautious than some of the smaller products. And I don't know if you're familiar with the concepts of the innovator's dilemma, but it more or less, it describes this. It's a very common business problem, which is, someone who has a very large product is in this position of not wanting to harm their existing business, but that means that it prevents you from going after new business opportunities. One of the things that we do is we have pre-stable channels where we can test things out for smaller groups. We have Canary, Dev, Beta, and people who install those kind of opt into a little less stability, a little bit more experimentation, and that lets us try things out without necessarily shipping it to, a few billion people. So that's, and we also heavily rely on user research. Like we run user studies and things like that.
Thank you. A quick follow-up though. I've noticed this strategy being used in Firefox where they have different flavors of their browser. For example, they launched Firefox Focus, which is different from their main browser. Is this a good idea for a big product like Chrome?
Oh man, we've had so many debates about that. We've had so many debates. A few years ago, I wanted to make another brand. I was told no. I totally see why Firefox is trying it. I think it's an interesting product strategy. At the same time, it divides your user base. And, if one turns out to be a flop, you might not get those users back. So it's not always a clear path forward. And then also you have to, maintain two separate products over time.
Thank you.
So I had a question about new web features. Well, I guess some are not so new anymore, but introducing new features, new web features, new APIs in the browser, and how you approach that from, thinking about security. I'm thinking about service workers, for example, simply because I worked recently on security aspects of service workers. And Chrome seems to be very, actually, quicker than other browsers in adopting many of these new web technologies. But then, as usual, some security issues may come up. How do you respond to that? What is internally the process? Because like you said, you need to, in a way, move slow so that you don't break websites that have adopted that technology, but at the same time, you have to immediately respond to potentially somewhat critical security aspects.
So everything does go through security reviewers. I used to, in fact, review, I reviewed a number of new APIs. And typically there's sort of a public comment process as well as the internal review where feedback is taken there. Usually adjustments are made based on that. We also have kind of two mechanisms. One is, web developers tend not to adopt it super quickly. So we often will, in fact, have kill switches for things that we think are risky. It would, break the early adopters, but it allows us, this has happened once before. There was a critical security vulnerability, and from the server side, we just kind of shut off that API until we were able to fix it. This is kind of something that was newly launched. So it didn't have, these are early adopter developers, people are on the cutting edge, they're gonna be able to respond They're not like the legacy web where they're not being maintained. We also have this concept of origin trials where, web developers who are using these APIs know they're experimental and that they might get shut off. Let's see in chat. With respect to the Firefox focus question, can you leverage trying alternatives without harming brand through Chromium? Sorry, Paul, I don't fully understand your question. Could you unmute and...
So what I meant is, so there's other browsers which are Chrome-based, but are not Chrome. They're not affiliated at all with you. And so you can kind of learn, in a way where you were saying, oh, if we built something like Focus, well, maybe those users don't come back. But if somebody else is doing it, you can kind of learn from them to some extent. Obviously, you don't have the telemetry data from them and stuff, but it's just another variant on that question. And I was wondering if you'd thought about it.
So Chrome is interesting. There are actually two kind of halves to Chrome. There is the browser that we ship, and we call that internally our browser app team. I'm on that team. We're building a user-facing browser. And then there's the web platform team that builds sort of the parts of Chromium that other browsers use as well. And we have different relationships with other browsers. The web platform team is, of course, supporting Chrome, but they're also supporting other Chromium browsers in the process. The browser app team, we are building user-facing features, but we are competing with other browsers, right? They are trying to convince, like Brave is trying to convince people to stop using Chrome and move to Brave. But it's just an interesting dynamic, because we are simultaneously collaborating on web standards, as well as the actual underlying browser technology itself. And also there are competitors. So, there is simultaneously collaboration and learning from each other, as well as healthy competition.
Thanks.
All right, I'm gonna move on and we'll take more questions throughout. Next up, I'd like to tell the story of how I went from a researcher to a practitioner. 10 years ago, I finished my PhD at Berkeley. David Wagner was my advisor, and my dissertation was on understanding permission systems, Android permissions, Chrome extension permissions. I really liked what I was working on, and I wanted to continue doing it, so I joined Google as a research scientist. I wanted to work at Google because I wanted my ideas to go out to the world. I wanted to be close to the change. I didn't want to have to go through the layer of trying to send my papers to people at Google and persuading them to listen to me. At Google, I could theoretically at least just work on the thing I was researching. So I started off pretty firmly as a research scientist. And then at some point over the next few years, I went to bed one night a research scientist and woke up the next day as a software engineer. And, it wasn't a conscious choice, it just happened. At the time, I was working on a research problem. How do you design effective warnings? I ran experiments, I looked at data, iterated, wrote papers, and started running a team that did this work with me. When we found things that worked, we productionized and shipped them. I ended up overseeing and shaping most of Chrome's security UI, like how URLs are displayed, when warnings are shown, what warnings look like, what permission dialogues look like, when they fire, and so on. And some of this work was published. But at the same time, other people started coming to me, other engineers on the Chrome team started coming to me to ask for advice. How should I design this UI? Is this the most secure way to build this feature? And so I also started falling into the cadence of doing security reviews, the way the rest of the security team did. And since if you have security expertise, you can have impact by helping other engineers by sharing that expertise. So one day I realized that I was a security engineer with a side hobby of research, not a researcher with a side hobby of engineering. I didn't mind, but I did learn a few things in the transition from research to practice. The first is that there's no dividing line between research and practice. Now, there are clear ends to the spectrum. If you're exploring ideas that are never implemented, you're definitely working in research. If you're implementing things that are straightforward and pretty clear as to what it is you should be doing, that's definitely engineering. But in the middle, there are lots of engineers who are trying to build something for the first time or in a new way. And so they're doing research in the process. The second thing I learned was that, like, initially I had this idea that Google was this super state-of-the-art place, and I would go there and be one small part of an enormous research team that was doing mind-blowing security work that I couldn't have even imagined as a grad student. And I was kind of right, but I was also completely wrong. Now, in some ways, the Chrome security team was really cutting edge and still is. Chrome was built as a multi-process browser, for example, which is hard to imagine now, but at the time was novel and had largely come out of academia. I learned so much from those folks, also from the folks, for example, who are doing security reviews, who are triaging and patching bugs. At the same time, though, industry has blind spots, and Chrome is no exception. We have something like 1,000 engineers building a product, for several billion people. That means we're a highly leveraged team. So inevitably, there are areas that no one is looking at. At the time, usable security was one such area. So when I joined the team, I dropped what I was originally supposed to work on to see if I could bring some knowledge from academia to fill in that gap. And there are other blind spots that we still have. I also learned how work goes from academia into production. I originally had this idea that academics would send papers to engineers, and sometimes the engineers would like the idea and implement it. I was trying to do this. Like, I would send my papers to engineers and hope that they would implement them. The truth is, this almost never happens. It's possible, but it's not the most common path. One example that stands out is Cynthia Dwork's paper on differential privacy, which, has massively influenced industry. A lot of people, a lot of companies have tried to figure out how to actually implement and use differentially private systems, and some have shipped. That is a positive example of this path working. But the most common path is actually in people transfer. Someone with an area of expertise moves from a university to a company, and in the process brings research knowledge with them. This usually means someone finishes their PhD or postdoc and moves to industry, but it also happens with university researchers who do sabbaticals at companies and sometimes with longer internships. Two well-known examples in Chrome security were Adam Barth, who got his PhD at Stanford, and he published prolifically on web security. He was a very early Chrome team member, and he brought a lot of ideas about trying to stop or block cross-origin communication to Chrome. These ideas turned out to be very influential in the design of Blink and the browser architecture. Charlie Rice got his PhD at UW, where he worked on ideas about browser architecture. He joined the Chrome team, where he was key to Chrome's multi-process architecture. And then he later led an immense amount of engineering work to get to full site isolation, meaning to actually put each website in its own renderer process, which is something that we now take for granted. And you can see a very clear line drawn from his PhD work to Chrome's architecture today. The idea started with a Hotnet's 2007 position paper, and now that's how Chrome works. There's also, I think this is another common path, is there's a whole body of work that contributes to the zeitgeist. By that I mean, there are papers that shape how people in industry think about a problem space, even if no one is going and actually implementing the stuff exactly like the paper says. Examples of influential zeitgeist works, I asked a few of my colleagues what they find influential. A few that came up, the Handbook of Warnings. This has been a major reference point used during work on Chrome Security UI. Colleague Chris Thompson mentioned Phil Rogaway's The Moral Character of Cryptographic Work, which I think is a great read. This World of Ours by James Mickens, where he talks about real-world threat models in the funniest, but also the most dead-on way possible. And then a lot of measurement and user study work fall into the zeitgeist category. I read a lot of Kai and IMC papers, and so do many of my colleagues. And I find that they shape how I think, even if I'm not going and implementing the things in the recommendation section. Now, a challenge with these papers is that study populations tend to not be very diverse compared to the actual user population that we deal with in browsers. If you remember my discussion earlier about how totally different groups of people are, it's hard for me to know what to take away from a study focused on, for example, the network traffic of American college students. And I see this getting better over time. I think, more and more researchers are realizing, okay, I can't just talk about the network traffic of American college students. or do a study specifically on university students in Pittsburgh. I'm seeing people branch out more, but it's still a challenge sometimes in how I can find takeaways from measurement and user research studies. But my absolute favorite research papers where I think academia is ahead of this industry are the papers about specific niches of interesting groups of people. What do domestic violence survivors need? How do journalists protect their sources? What do sysadmins at small companies struggle with? What type of web browsing or app usage does someone who is illiterate or marginally literate do? As I mentioned before, Chrome and all of Google is highly leveraged. So these studies on kind of important subdemographics are really interesting and really important, and we're not doing them ourselves. So it's very, very informative, and I love reading these papers. They get emailed around and they kind of percolate and eventually might shape a decision or feature. All right, so for the last of my 3 stories, I also want to talk about how I left security by accident. So remember earlier how I mentioned that Chrome went from intuition-based to data-backed. That process changed me too. I had been doing research that looked a lot like data science, or what we call data science today. At the time, I didn't quite have a word for it, to improve Chrome's warning and HTTPS update rates. The same techniques can be used in other places to understand our growing and now huge user base. For example, understanding how well autofill works for filling in addresses for payment flows and things like that. And at the time, Chrome didn't yet have a data science team. There were just a number of folks with PhDs like me, a few others, who had an idea for how to interpret metrics and design experiments, most coming out of a research background. Myself, security, we also had some folks from networks and systems. So as a result, I started working on other features that needed help wrangling experiments or particularly gnarly data. And then I started a proper data science team because it turns out we needed real statisticians who know a lot more about statistics and focus on this professionally. And then eventually, because I was working on these other things, I couldn't realistically also do security work anymore. It didn't make sense. So these days, I don't do security. I manage product engineering teams and oversee experimentation and data science. I thought I would share a few ways, though, that security engineering or security mindset have been helpful in work outside of security. So a core part of our security team was doing security reviews. I spent a lot of time picking up some random Teams feature, learning about it, and trying to find all the ways that it could be broken or misused. I had to do this quickly because there's endless reviews. I had other work to do too. And it turns out that a key part of being an engineering manager of a product engineering team is being able to pick up a design doc, read it, get an idea of whether something is going to work or where the problems might be. Very similar to doing a security audit or security review. Being in security is also a great way to gain breadth. I developed over time a solid sense of how lots of different types of systems work, even if I never myself directly wrote code or worked on them, because I had to familiarize with myself in order to look for security challenges. Also, when working in security, you have to be able to identify and reason about risk. Not all risk is equal. When you triage security bugs, you have to have criteria for what might make something critical risk versus low risk. Well, it turns out that bringing that approach to other areas of software is helpful too. Having clear criteria, classifying, prioritizing, it's a core skill set. And when you're doing a security assessment, you can't possibly understand every part of how the system works, but you still need to know enough to know what might break. So you have to grow very comfortable working in ambiguity, knowing what parts of a system are designed to pay attention to and which to ignore. This is a generally valuable skill set that I see a lot of other people struggling with outside of security. With that being said, there were also a few surprises when I moved from security to product engineering. Security is clear. You know what your mission is, which is to help people, to help keep them safe. I felt great about that, and I always felt confident that I knew what the right thing to do was. In product engineering, the mission is less clear. You're sort of defining for yourself, what is the thing we're building? What is it we're trying to do? And also the sense of mission in security space brings, in my opinion, a feeling of closeness, of camaraderie in security teams and also in the broader security community. Your shared purpose and shared skill sets bring you together. I, in the past, was on the security team, collaborated with people at competitor browsers, because we're all working on security. And I found this missing in other spaces. And on the security team, security was always my top priority. I didn't have to be the one who would balance a security trade-off with something else. Like earlier when I was talking about, the decision of whether to launch a compression proxy similar to UC browser, I was on the security team. I only had to provide the security perspective, and then someone else had to weigh these things against each other. Now, because I've moved off of security, that's often my job of trying to weigh the concerns or feedback from the security team with other competing goals that we're trying to achieve. This feels painful, right? But something I've also been pleasantly surprised about is how much non-security engineers want to learn about security. Like, I didn't quite appreciate this when I was on the security team, but people who don't work in security have this like deep respect for the mystical security people who know how to break everything and really, really have an appetite to learn. So I've been pleasantly surprised by that. So I'll leave you all with this. I've loved being part of the security community. And I carry that with me even now that I'm not working in security anymore. And I feel privileged that I was able to take what I learned from the research community and use it to build security UI for billions of people. Thank you all for having me here.